Well, everybody, I am very excited to chat about this topic today. Artificial intelligence is something that I'm increasingly interested in. I'll give you a disclaimer. This may be the nerdiest presentation that I've ever given, which makes me even more excited about it. We really go in depth in this. As a general overview of what we're going to cover, the first part of it is talking about what artificial intelligence is. Big spoiler here, it's very different than what you see in Hollywood from the movies and stuff. So I want to clarify that so that we can get the appropriate context so we can talk about part two, which is how does this apply to the search engines? And more specifically, how does this apply to Google and what does that mean for us as marketers, as SEOs, and as other kinds of marketers? And then the third part is what does this look like in the future? AI is developing very, very fast, and I have some thoughts on what I think this is going to look like in the future. I'm also going to touch on the question that comes up far too often with AI is, are robots going to kill us? And I have what I think is a well thought through answer for that, something that may surprise you. So with that, let's jump in. What artificial intelligence could mean for SEO and for the future? So first question that comes up is what or who is AI? And there actually is a very specific definition for this. I'll give you the quick one and I'll give you the one that I think is more useful. The quick definition is an attempt to replicate human intelligence using computers. And my guess is you probably already knew that. But in order to do something, especially being data-driven marketers, we need to be able to measure that, to be able to know if we've done that or not. So what we were doing is we have a level of computational competence that we use measuring something called the Turing Test. Now, if you've never heard of the Turing Test, it is something that is becoming more and more popular with the general public. I've just started to hear about it in mainstream news over the last year or so because people have been claiming to beat it, but no one has been able to do it yet. So let's dive into what that means exactly. The Turing Test is a test developed by Alan Turing. He just had a movie that just came out about his life. I don't remember the name of it, but I'll look it up when we're doing the Q&A. As kind of a side note here, the only public domain pictures of Alan Turing are of him as a kid, but when he came up with this test, he was much older, so bear with me there. The Turing Test is how we define actual artificial intelligence. So is a computer as smart as a human? In order for it to do that, it needs to be able to be intelligent and achieve human-like performance in all cognitive tasks sufficient to fool an interrogator. So the interrogator doesn't see the computer, they only interact with it, so maybe it's through chat or maybe it's through video or through other means, and needs to do all four of these things. And these four things are very foretelling about Google's participation and usage of artificial intelligence. So according to the Turing Test, which is how computer scientists measure if something is actually artificially intelligent, it needs to understand natural language processing, so it needs to be able to communicate successfully in any human language and needs to be able to ask questions and respond to questions intelligently in a way that fools the interrogator, the human that is talking to it, so they think they're talking to another human. It needs to have knowledge representation, so it needs to understand what is being discussed. It needs to be able to make assumptions, and it needs to be able to make informed decisions about how one area of knowledge relates to another area of knowledge. It also has to have automated reasoning. So it needs to store the information that is being communicated during the conversation and then show it and be able to draw new conclusions from that information. And the last has to use what's a technique called machine learning, which is to adapt to new circumstances and detect and see patterns. So this is of particular interest because Google, as all of you probably know as smart marketers, is working very hard on all four of these areas of testing areas of artificial intelligence. So natural language processing, you've been able to see as the queries have gotten smarter. So if you ask something like, who is the President of the United States, it might say something like Barack Obama, and then if you say, who is he married to, it understands that you're still talking about Barack Obama. So that would be an example of natural language processing, of the automated reasoning, to a very small extent machine learning. These are all four areas that Google is specifically targeting so that they get closer to this idea of artificial intelligence. So we have the Turing Test. This is how we measure true artificial intelligence. And I'll give you the quick spoiler here. No winners yet. We had two people who tried to compete on this with different chat bots this year, and they both did not win. So in fact, we've actually had no computers that are truly artificially intelligent, as in as smart and foolable as a human being to an interrogator, being one human being trying to decide if they're talking to another human being. So no winners yet, but we're getting very, very close. When we're talking about AI, and at this point it's now clear that AI is not exactly what we see in the movies. It is something that's a little bit more dumbed down. When you're talking to Siri on your phone, for example, or when you're using Google Now, you can still tell that you're not talking to a human. You can still tell that you're talking to a computer. We have not reached true artificial intelligence yet. We're just getting closer. So when we talk about artificial intelligence, it's much easier if you break it down into two broad categories. So you have narrow AI, and again, all this is going to tie back into search in part two. I'm just saying the context at this point. You have narrow AI and you have wide AI. So narrow AI is something like Google's smart cars. They can do one thing and one thing very well. So in that case, they can drive around the streets of the world. Or you have a different kind of AI, maybe sponsored by Google, maybe sponsored by someone else, that can do chess, and it can play chess very, very well, and it can beat any human in the world at that game. Or you have the AI that runs our bank fraud detection globally, and that can do one thing very, very well. So the narrow AI, which is what we have most of today, is it can do one task and only one task. There's no and, it's only or. It can do bank fraud detection, or it can drive cars. Wide AI, which is what is becoming more important and starting to grow more this year, is kind of what the true definition of AI would be. It would be a computer that could drive a car and play chess and detect faulty transactions in banks. Something more akin to IBM's Watson that's been making headlines recently. It can play Jeopardy. It can also do web analytics. It can also do a whole myriad of things, not just one thing like the narrow AI that we've seen in the past. So who's doing artificial intelligence research? Well, it turns out there's lots of companies. There are the companies you might expect. So Microsoft, Amazon, IBM, Google, Apple, Uber actually hired almost the entire graduating class of robotics in MIT this last year. So they were working very, very hard in artificial intelligence. You also have universities. These names are not surprise you. So you have Berkeley, Stanford, MIT, University of Washington, University of Waterloo up in Canada. They're working very hard in these areas. You also have major brick and mortar based companies. You have Kroger, Walmart, Costco, Carrefour, Road, all these other ones who are working very hard on this because they see a lot of potential in this kind of technology. You also have a lot of governments. So we have Russia, China, Germany, UK, United States, India, and a plethora of other companies and governments and organizations. They're all working on AI. So there's lots of people who see that this could be important. And there are lots of people trying to pass this Turing test and trying to get this true wide AI because they know that it's going to be able to affect many, many things we do. So let's talk about what this looks like today and yesterday and what this looks like going forward, and again, how is this going to affect search? Well, for today, we have some very narrow, although sometimes high-profile examples of artificial intelligence. Again, it's not true artificial intelligence. It doesn't pass the Turing test, but it does simple things very, very well. So you have machines that can play chess very well, or you have Tesla that has these self-driving cars that can do that, or you have Google that has the self-driving cars. You have something simple on your phone like Siri or Cortana if you have a Windows-based phone. They can kind of understand your voice, although it only works to about 80% accuracy depending on a couple factors. You have a service like Spotify that is very, very good at recommending music and streaming music. Or you have something like Google Now, which can do a few things well, but is rapidly expanding. So that's what it looks like today and yesterday. Today and tomorrow is where things start to get a little more interesting. So very recently, the other search engine that's not talked about very much, Wolfram Alpha, which is a computational search engine, is a little bit different. It's more based on advanced mathematics and data sampling and data manipulation than it is on natural language queries. Released a function called image detect. And using this, and again, it's just a piece of code that you can call on any program. It is very, very good at taking any photo you give it and then tying it back to what it represents. So if you take a picture of a hard drive or of a cell phone, it knows no matter what angle you take it at or what the lighting is or what color the object is, it can tell you with high precision of accuracy what that object is. This is interesting because it's not just revealed as a technology, it is revealed as a function you can call in any kind of code that you want. So that makes it much more interesting because it becomes more platform-like. You also have AI services coming out. So XAI is a virtual scheduling assistant, which is starting to make waves right now. This is something that appears as a human. You attach it to your email addresses and it acts as a virtual assistant using natural language processing, so it talks just like a human being and schedules your meetings for you. So this is interesting because it's an example of people not understanding or knowing that they're actually talking to a machine when in reality they really are. And then you have a lot of the work that Apple's doing. So you have Apple Music, which is basically just a clone of Spotify. But all the data they're gathering is starting to show that they're looking at something much wider, much bigger. It's not, I think that what Apple's trying to do with Apple Music is not just become a clone of Spotify, but to become something much wider, much more akin to what Google is also trying to do, which is Google Now with all the Google technologies. And in the future, I think what we're going to see is we're going to see platforms. So AI that'll be sold as a platform or as a service like Amazon does with computational power right now. You have something like IBM's Watson, which can do many, many things. Again, it can play Jeopardy, and it can drive cars, and it can do web analytics analysis, and it can do many, many things. You have Google Search, which possibly led by DeepMind, which we'll go into, which is a company that they acquired, is starting to do much more than it has done in the past. And then you're going to inevitably run into private AI platforms. So these different companies and these different governments that we've talked about are also working on AI, so they're going to have their own proprietary AI platforms. Okay, so that's been a lot of theory and context. Now I want to dive into how does this apply to you and I as marketers who work specifically with Google and to a lesser degree with the other search engines. But how does all of this apply? What does this mean for us? Well, in order to do this, we need to dive a little bit deeper into AI and what it is and what it looks like. So one approach at artificial intelligence, and again, there's many, is something called machine learning. You may or may not have heard of this before. It is a subset of artificial intelligence. Again, it is one approach at trying to create true artificial intelligence. It's building machines in a way, programming them in a way where they're able to learn from mistakes and then get smarter from that. So this is a general concept called machine learning. We'll dive into the nitty-gritty technical parts of this. There's 3 different kinds of machine learning, and trust me, this machine learning is something you're going to be hearing a lot about going forward. This is rapidly becoming the basis of Google's algorithm. So if you haven't heard about this now, that's okay, but it's important to pay attention to what this concept is, what this approach is, because this is very, very important to the work that we are doing as marketers, because this is going to be the underlying technology for a lot of what we do going forward. So again, machine learning, it's a way of programming machines so they can learn from their mistakes and then improve on that and do better results going forward. So there's 3 different kinds of machine learnings. There's supervised learnings, so you give it a subset of good information, or let's say bad information, and then it can go through a whole lot more information and it can tell you what is good and what is bad. So a great example of this would be a spam detector. This is a technology we've had for a while. You give it a list of spammy emails, you then let it see your entire inbox and all of your email history, and then it can tell you with a high degree of accuracy what is considered spam and what is not. And this is actually the one that applies the most to search, and we'll go into that in a couple slides from now. The next one is unsupervised learning. So it takes a whole bunch of information, say the entire corpus of Wikipedia, so all the data and all the articles on Wikipedia, and then it starts to figure out how they are related, and it maps them in a 3D map so they can say, okay, countries should be in this corner with their leaders closer to that, whereas like flowers should be on the opposite end because flowers don't really have anything to do with countries. And it does this for the entire corpus of Wikipedia until you get to a point where you can start understanding how different ideas and different concepts and different articles are related to each other. So this technology certainly exists today. It's a lot of how the knowledge graph works on Google, but it is, again, just one example of machine learning. And the last one is something called feedback right-wrong, and this may actually be the most straightforward of the group. This one takes reinforcement learning, so a machine will play one move, let's say it's a move in chess, and if it wins or if it loses, then it says, okay, and it learns a little bit from that, and then it goes forward. This is actually more similar, I'd say, to how humans learn. But what it does is it'll do this over and over and over again until it gets very, very good at it. And when we talk about DeepMind, which is a company that Google acquired last year, this is the technique that they've used, and it's starting to make a big difference in the way that Google serves ads. That's a little heads up of what I'm going to talk about in just a moment here. So with artificial intelligence, you always get the question of, well, what about the human brain? So it turns out that we don't know a whole lot about how the human brain works, and we have neurology, right? And we have lots of very smart people who are working on this, and they've made a lot of discoveries, but I think we're still in the infancy of neurology. So computer scientists can only use a little bit of this. to influence their programming. So what they've come up with is this concept called neural networks. And this, again, we're really diving in deep here, getting into the nerdy stuff. But it's because this is becoming the foundation of how search is starting to work. But a neural network, I don't want you to think that it is an exact copy of the brain. Instead, this is just a very loosely based programming style that is based off of the biological human brain. The idea here is that you feed it some kind of information. So in this example, a picture of a cat, and then it looks for familiar symbols or familiar representations. So in this case, it may just take the image, and then it says, okay, here's the parts that are considered dark, and here's the parts that are considered light. So it's very, very high level. And it says, okay, this shape looks a lot like a sphere, and then right next to it, I can see there's another sphere, and then it goes on the next level, and says, okay, a lot of times when I see two spheres next to each other, those are eyes. So it goes through step by step by that, and what it can do is spit out very simple information like cat, which is text-based, which is interesting because this is an example of machine learning using neural networks to understand what a picture actually is as opposed to what it may look like. The really nice thing about this, and you've already seen this in Google search and on Bing search with images, is that you can have a cat, maybe it's a cheetah, or you can have a cat, maybe it's like a small household cat, a kitten, and the machines get smart enough where they can understand that those are both cats, but separate versions of cats. And it can tell you that information. It can tell you if it's a cheetah, or it can tell you if it's something else. So this, again, is very loosely based off of how the actual human brain works, but very, very loosely, neural networks. So what are neural networks good for? Well, they can do these four things well. They can take pixels, and they can tell you what it is, which is helpful. This is what we see in image search all the time. They can take audio waveforms, and they can start to break it down and understand what you're saying. This is exactly how a lot of the Google technologies work, is using neural networks, which again is an example of machine learning, which is a class and an approach within artificial intelligence. I'm trying to put everything in context for you here. It can also take one query and a multitude of docs. This is how search works in general, and it can tell you what is the preferred version. So this is showing that, hey, this is a useful technology for search engines. And the last one it can do is translation, which, hey, this looks very similar to the work that Google is doing with Google Translate. So again, we're seeing these underlying technologies, we're seeing them get more popular, and we're realizing that these align very, very well with the goals of Google and with the technologies we're seeing come out of Google as consumer-facing products. So again, we have image search. The second, we have all of the voice recognition. The third one, we have search itself. And the last one, we have Google Translate. It's interesting, neural networks. And again, all this information is coming directly from presentations given by Googlers. So in this example, it's a presentation by Jeff Dean, who works at Google, and works on this kind of stuff. All right, so at this point, how does this apply to internet search and you and I? We've drawn out some patterns at this point. We can see these technologies are coming out, and they align very well with the kind of consumer-facing products we're seeing from Google and Yahoo and Bing. So let's go into this a little bit. So here's what we optimize for today with SEO. We optimize for things like title tags and URLs and H1s and alt text. This is hopefully a review for you. These are what we consider factors, right? And Google's said that they have about 500 factors or so. Most of them have to do with links, but many of them don't. They have to do with different kind of engagement metrics and with actual information on the page. So this is what we spend all of our time working on today, is optimizing for these factors. So if I made a rough diagram, which I have here, this is very, very simplified version of how a search engine might work. So on the bottom left, you have the web, which is ever-growing and gigantic. It then gets filtered by Google's crawlers and by Google's servers and data processing units into SEO factors. So we have, last I heard was 500 plus. And then through that lens, it gets fed into the Google search algorithm, or any search engine algorithm. And this is an important difference here, because you have not the raw web going directly in the algorithm. Instead, you have the web broken up into these factors and then looked at from a search engine perspective. It's not the raw web going into the algorithm. It's just this one lens that goes through these different factors that we've identified that go through the algorithm. The algorithm itself is, of course, written by very smart people who write search engine algorithms. So at Google, this happens in Mountain View. For Microsoft, this happens in Redmond, Washington. There's people who write these search engine algorithms, look at the results, and decide if it's better or worse. So Then humans come and they ask search queries against this, and you get search results. Okay, so that's how, in a very simplistic way, how search engines work today. And the bigger takeaway here is that humans write the algorithm. Now, when we're looking at machine learning, we see that things work very differently. With machine learning, machines don't necessarily look at factors per se. There's no lens of the 500 or so factors coming into the algorithm. Instead, they use training data, which in this case would mean search results determined are very good. So Google may choose a bunch of search topics that they know that they've done really, really good at. Let's say that they think that they have the best sports results for, say, hockey. And they will feed in as training data. These are wonderful search results, and we know these are really, really good. They also feed in data about, okay, we're really good at politics, and we're very good at medical-based search queries, for example. And they'll feed these as training data. We did a great job at these. We want you to take that information and then apply it to the rest of the web, which, as you know, is a whole lot of data. What's interesting here is then the computers themselves write the best fit algorithm, not humans. So you don't have the people saying, well, we should see if title tags are a good metric, or we should see if links are a good factor. It doesn't work like that at all with machine learning. Instead, you feed it good data, training data rather, and the machines themselves write the algorithm. What's crazy here is that you cannot go in and, or at least it's extremely difficult to go in and reverse engineer how a machine that used machine learning came up with any given result. So you can't say that this page is ranking well because of X, Y, and Z when the results were caused by machine learning. So this is kind of an interesting concept here. What's even more interesting is the factors may not even be factors exactly. So we look at things like title tags, alt text. They may be looking at something completely unrelated and something maybe we as humans can't even see or understand. Maybe it's a mathematical concept that happens to lead to new and good search results. Okay, so here's the old model. This is what we use today. It's a human-led algorithm. The web comes in, we filter it into the lens of hundreds of different SEO factors that you and I as marketers use and optimize for. People on the internet, this is at the top of the diagram here, do their search queries. It then goes back into this algorithm and you get search results. That's how it works today. It's human-led. Machine learning, though, works very differently. Notice that we, on the left here in this red section, we don't have factors anymore. We don't have the things like title tags and links anymore. We have just training data, which are whitelisted good search results for any given topic. That goes directly into the algorithm. The web itself goes directly into the algorithm. We don't have the lens of these factors anymore. People query that machine written algorithm, and you get search results. So you've taken the humans, they're not writing this algorithm anymore. The machines are writing the algorithms. This sounds very sci-fi and futuristic, but this is actually how machine learning works today. We don't think that they're doing it at a web scale, but we'll get into exactly what scale they are doing at. But this is a very, I think, futuristic and important idea that is not well established and well known by marketers at this point, that if they're using machine learning technologies and techniques, which they are, the way the search engine works and the way that we as marketers need to react to it fundamentally changes. It's not based on factors anymore. It is based off of things that are very much more difficult for us to understand and try to optimize for. Okay. And I'll go over this just one more time because it's so important and because it's a very complex idea. So with the algorithm as it currently works for search engines, you have the web. The web gets fit into the lens of hundreds of different factors that we as marketers can optimize for. These then get fed into an algorithm that's written by a bunch of smart people as search engines. People query against that, and then you get search results. So this is how it works now. With artificial intelligence and with machine learning, it completely changes. You get rid of all those factors that we use today. You have the raw web filtered into and fed into an algorithm that's not written by humans, not by computer scientists, but instead by machines, by machine learning. That then takes the information that's fed to it as training data. You get people who query against this using a search engine like Google, and then you get the results off of that. So I'm sure there's going to be a bunch of questions about this. You can ask about them in the Q&A. But this is very, very different than what we have been used to. Again, this is all examples of narrow artificial intelligence using an approach called machine learning. So what might we be optimizing for going forward? Well, we don't know yet because the factors will, if they go this route, the factors will not be clear. It won't be as simple as optimizing title tags and keyword usage. It's going to be things that are much more complex, and these are some of the ideas, but again, some of them might be things we just can't optimize for. But it could be things like long to short click ratio, meaning does someone go to a search engine, click on a result, and stay there, or do they go back and forth? Are searchers conducting additional related searches? Are people having high metrics of user engagement? I think this would be measured through something like Chrome, Google's Chrome. You have relative click-through rates across results given different industries and different topics. You have the amplification rate, which would be similar to sharing data, although I don't think the search engines, at least Google, uses sharing data directly. I think they just get proxy data, so information looks very similar and acts very similar to search result or to social shares, but it's shown in a different way. And then you have user engagement on pages. So you can tell this is going to be much, much more difficult to optimize for because this isn't as simple as just making sure you're using the keyword and the title tag. Instead, it goes more into how people use websites and how people use computers. So this is what we might be optimizing for going forward. Okay, now all at this point, it seems a little bit confusing, a little bit strange, a little bit maybe overwhelming. So let's go and talk about some of my data sources here. So is all this for real? Yes, all this is certainly for real. I have friends who do machine learning for a living. I have lots of presentations and patents about Google using machine learning. But at this point, it is unclear how widely used is used in search results. So let's go into that a little bit. So I mentioned twice now this company called DeepMind. DeepMind, I believe, is a UK company, UK-based company, that focused on artificial intelligence. And in January of 2014, Google acquired them. Now, what's interesting about this company in particular, because as you know, Google acquires lots of companies, is that DeepMind, really their claim to fame, what they had done that was better than anybody else, was they used machine learning techniques, which is not particularly rare. Lots of companies do that. But they used the reinforcement technique to play simple video games. And this actually went viral on YouTube. You may or may not have seen it. But they had a very simple algorithm, or at least an algorithm. I don't know how simple it was. And it initially played very simple games. So it played Breakout, it was a video game, and they played Space Invaders, it played Tetris, I think it played Mario. And it did these, and when it made a mistake and it lost, it then started again, and then learned from its mistake and got better and better and better. So this by itself is not particularly interesting other than it's kind of fun to watch on YouTube. But then it started to grow. It got smarter and smarter and smarter, and it started to be able to do things that were more complex than just video games. It started being able to do things like serve ads or work as a recommendation engine, the same kind of technology that powers Amazon that says, hey, you looked at this object, I bet you'll probably like this one as well. So as it got more data, it started to get smarter and smarter and smarter. And then we lost access to this company because we as the public, because it got acquired by Google. And not just a small acquisition, it got acquired for $400 million, which is significant. They certainly saw a lot of potential here. Wired did an expose on this company not too long ago. I think it was in July of this year, of how it's being used at Google. And this is a company called DeepMind. And it's being used today to power YouTube ads. So if you've noticed in the last year after this acquisition, YouTube ads and the YouTube recommendations have gotten significantly better. This is something I've noticed and that I've talked to other people and they noticed this as well. And we find out in July of this year that this was because DeepMind's technology was using machine learning, using simple, narrow artificial intelligence and reinforcement learning to be able to show these things. Now this is quite interesting because YouTube is many times a testing ground for Google's bigger technologies. And through this Wired article, we also find out that the team at DeepMind, which is owned now by Google, is offering their service internally as a programming service, meaning other departments within Google can start using this. So it's primarily used by YouTube right now, which again is owned by Google, but it is offered as a service internally so that anybody can use it. Interesting. We also have thought leaders in the space. So Fishkin, he's the founder and former CEO of Moz. He's one of the, I think, premier SEOs in the industry as far as understanding what is coming up and accurately predicting what is next. Rand is a very strong believer that there are two algorithms being used for search right now. One based on the traditional factors like you and I have taught, and then one that is based off of machine learning that doesn't use factors at all. Instead, it uses training data. And he thinks that they're both being used right now. And this is interesting because in the last 2 years, but the last year especially, you may have noticed there's lots of results that don't seem to fit the same patterns that we've seen in the past. You'll see things that are ranking, and they are really good results, but it's become very, very hard sometimes to figure out why it's ranking. So it may be ranking number 1, and it may be actually the best result, but it's not because it has the most links or because the title tag is there. Instead, there's something else at play. So people like Fishkin think this is because there's a machine learning algorithm that hasn't completely replaced the old algorithm, but he says they're being used together. And frankly, I think that's right. That seems very accurate, and it explains a lot of the strange behavior that I've been seeing with search results over the last year. And Google and Rand specifically think that AI certainly has the potential to provide better search results globally and for all purposes. It's just a matter of getting it there. And at that point, if we get there, then it is certain that Google would go towards a all artificial intelligence-based search results rather than what we're used to today. Again, just to reiterate that's not entirely what they're using today, although there's some evidence that they're using maybe a dual algorithm approach, that they're supplementing the old algorithm, the one that's factors-based, with machine learning today. But if they can get to a point where AI produces better, more important, more accurate search results, there's no question that they would move all the way over, because Google's main goal is to provide the most accurate and useful search results possible. Which brings us to Google's predicament at the moment. So they're seeing machine learning approaches do really well at many different types of tasks. Remember, they have the Google Translate, they have the Google Now, they have all the voice recognition that's going on. They have the traditional machine learning, which is how you get from a picture of a cat to a cat, or you have the natural language processing stuff. And they've tested it on YouTube, and they've shown that actually it can do a really, really good job of showing recommendations and of showing ads. So then brings up the question, well, why don't they just flip it over to AdWords? Right? If it's already doing a great job on YouTube, why don't they do it for all of AdWords? And of course, YouTube uses AdWords as its way of doing showing ads, but it's only for very specific kinds, specifically video ads, so in-display and in-stream. But why not roll it out to the whole system? Well, if you're in Google's shoes, you have kind of a conundrum here, a predicament. You want to always do the best job you can, but you don't want to risk what is making most of your money. So in Google's case, the vast majority of their income comes from AdWords with traditional ads, or variations on traditional ads on the web. And they do not want to take their well-publicized and semi-transparent AdWords auction-based system and put it into something that they themselves will not be able to reverse engineer. Again, that's one of the downsides. Maybe you could say downside of machine learning is that the computers write the code, humans do not write the code. And I think Google is a little bit scared, a little bit skeptical that they don't want to switch over the thing that makes all of their money over to a power that they cannot themselves reverse engineer. So again, this sounds very futuristic and sci-fi, but I think this is a legitimate concern they're dealing with today in today's world. All right, so this jumps it up a little bit. We're going to take it into how this affects us at kind of a higher level. Are artificial intelligent robots going to kill all of us? Well, I'm going to talk about this without going into hyperbole. So the question itself is kind of out there and crazy. But I want to talk about how computer scientists and how legitimate technologists are approaching this problem. And I want to explain why a lot of them are legitimately concerned about it, but I also want to talk about some of the different perspectives. So we have kind of a funny ha-ha sci-fi question here, but I want to approach it in a realistic and real manner because I think that this analysis of this question will actually surprise you. So a lot of very smart people think that surprisingly the answer to this is that it is probable. And this, I mean, think about this for a second. Are artificially intelligent robots going to kill us? And the answer is it is probable. Not going to happen for sure, but it might. Let's talk about what this means. So here's an example of 4 people who are both very fearful but very excited about artificial intelligence. You have Elon Musk, he's the former founder of PayPal. He's Tesla and SpaceX, a few others. You have Andy Rubin, who is the creator of Android. He created Android at Google. It got really successful when he left to do his own incubator. You have Bill Gates, started Microsoft. You have Ray Kurzweil, has been talking about these things for a long time. He wrote a book called The Singularity is Near, which is about this concept. You also have people like Sam Harris. You have a lot of legislation going through major governments at the moment about these kind of things. Steve Wozniak, to a lesser degree Steve Jobs, because he wasn't as concerned about this. You have a lot of technologists. The founder of Skype just did a major conference on this very idea. All of these people see that AI could get too powerful. It could become so much smarter than us that it would no longer care about our concerns and would start to overpower us. This is a legitimate concern that these very, very smart people are having. So let's dive into that. What are people talking about? Well, all of this is based on a quote-unquote problem called recursive self-improvement. And this is something we saw happen with DeepMind as they got good at video games, and then they got better at something a little more complex, and they got something better, a little bit complex, and you can imagine that it grew very fast until they got acquired by Google before it could get really, really big. So all of this comes from a computer science project, computer science approach called recursion. Recursion is code that calls itself, so it's meta. It is code that does one function, and within that same function it calls itself. That's a little bit confusing. It actually took me I'm a computer science by trade, and it took me a while to really grasp what that meant. But the idea is it's code that calls itself. It's complicated because you'd think it would end in an infinite loop, but for various reasons it does not. Where this becomes problematic is when you have a computer that can write code that can code it. Excuse me. You have a computer that can code itself to code itself better. Then you do run into a big loop problem. Now, if a computer can learn how to write code, and computers certainly can, as they can learn to play video games or play chess or play Jeopardy, for example, as IBM Watson did, or analytics. If it can learn code, which we think that it legitimately could, there's nothing to stop it from writing code that makes itself better, and then using its new learnings to make itself even better, and then continue until it surpasses the Turing Test first, and then human intelligence, and then it could go even further in theory. What we're running into here is a problem of exponential growth. We've seen this in technology, that as you know, technology and computational power has been growing exponentially. We've seen this for a long time. But what people are doing is they're starting to look down the road a little bit. They're trying to look in the future, and they're like, well, if we keep growing at these speeds, what's going to happen? So let's use a stick figure drawing to talk about this a little bit more. This may be how you view the world. This is very similar to how I used to view intelligence levels. So you have something like a dumb human, that's the green line in the center, that might be me. And then you have someone very, very smart, like Einstein, or you can pick your favorite scientist. And let's say they're twice as smart as I am. And maybe we'll just assume for purposes that is true. You then have things that are much dumber than humans, or less intelligent would be a better way to say this, like a chimpanzee, or a bird, or say an ant. And those we view as very, very like dumb or lacking intelligence. The problem here arises when you start quantifying these things and you start measuring it. So on this slide here, you can see what it's closer to actually looking like. So the smartest human being in the world may just not be twice as smart as the average person. They're probably just a little bit smarter. And then chimpanzee is probably like a fourth as smart as a normal human being. You have something like a bird and an ant below that. Well, artificial intelligence, which today is not particularly smart, but is quickly growing, it can grow at an exponential rate, we think that by the time it reaches and passes the Turing Test, and this could be from Google's doing, or from Microsoft's doing, or from just someone in the middle of nowhere who creates this technology, we think that it's going to be able to write code that can make itself better and then grow to a degree where it surpasses even the smartest humans very, very fast. And I'm going to pause here again, because this all sounds a little bit crazy until you start thinking about it. And remember, people much smarter than myself are legitimately concerned about this. These are 4 examples, but if you go online or if you look at any newspaper talking about artificial intelligence, you have legitimate scientists and you have very smart technologists who are very afraid that we're going to run into the pattern that we see here. That imagine that if something as, say, like our intelligence compared to a chimpanzee. Like a chimpanzee doesn't have like a vocal language. It can understand simple things like body language, but it is very far away from our own intelligence. If you had something that went from the level of, say, chimpanzee to human, from human up to the same level going above us, that's almost incomprehensible. It's almost hard to imagine how smart that thing would be. And people are worried that that thing will be computers and it will get very, very smart. Okay, we can talk more about this in the Q&A, but it's a little bit concerned. Let's get a little bit away of the doomsday effect of this. This slide goes over the things I just talked about, that you run into problems with machines getting much, much smarter than us. So let's talk about other viewpoints, and we can talk about this again more in the Q&A. So the best way to study the future is to study the past. So some parallels in history. One of the great technologies that we saw invented that was very, very both important and also difficult for the common person to understand was electricity. When electricity first came out, people were like, you can take lightning bolts and you can make like my fan spin, or you can power my mill. This is just a crazy concept when it first came out. And you take some of the thought leaders there, so Tesla, right, not the car company, but the actual man, his vision for the Earth, or one of them, was to give everybody free electricity by beaming electricity from the atmosphere. And when your house needed electricity, your house would get hit by lightning in a controlled way, and then that's how you would power everything. And that was a legitimate way that he wanted power to be distributed. And in many ways, it's actually interesting because that is more efficient than the way that we distribute electricity today. It's just you have the downside of your house has to get continually hit by electricity, which is terrifying. But this is what scientists really thought at the time of how we were going to use electricity. So it's very natural when you have a looming technology that is very, very powerful, like artificial intelligence or like electricity in the past, to be really scared of it. I think that's a very legitimate feeling. And so what you run into here is that you have a lot of very smart people who may just be very afraid of something that they don't understand. And luckily, if AI plays out the same way electricity did through history, we may be able to harness and control it. And then we could use it, and then we as marketers will adapt, and we will figure out these new ways of getting our search results to rank well, to get our pages to rank well. And it'll be something that we're less afraid of and something that kind of starts to fade into the background, much like electricity does today. So there's the one viewpoint of people being very scared of this technology. There's the other viewpoint that it may just play out how other major technologies throughout history have played out, which is they eventually just blend into the background. All right. If you think this stuff is interesting, or if you want to check any of my notes, here are a bunch of resources you can check out. By far, the most important article that I've read on this, especially for when I started as a beginner, is this first article here was on a website called Wait But Why. It's called The Road to Superintelligence. The next one is Rand Fishkin's MozCon 2015 keynote. You can probably find that online. Google's, through their engineers, have talked a lot about this stuff, Jeff Dean in particular. And you have DeepMind. You can read this article for free online from Wired. This is Wired UK, this example. So if you're looking more information on this stuff, these are the places to find it.